Welcome! In this video I will explain how to run quantum algorithms using the web interface of Quantum Inspire. While the SDK provides powerful mechanisms to write complex quantum algorithms using Python, the web interface provides a nice visualization of algorithms. The only thing needed to use our web interface is a user account. If you go to our homepage, quantuminspire.com, you will see that it comes with a knowledge base, a button to go to your own projects, and the best way to contact us. Make sure you check out the knowledge base, because it provides you with all kinds of information on how to use the system in the most efficient way. It also contains some basic programming examples to get you started. If you don't have an account yet and click on My QI, you will automatically be directed to a login page where you can fill in your name and email address. Make sure your email address is correctly filled in, because it will also act as your user account. You can pick a password of your choice that is at least 8 characters long. When you register a new account, you will receive an email confirming your registration. The next time you will go to the web page, the My QI button will bring you to your own workspace. When you are a new user, your list of projects is initially empty. However, after creating one or more projects, you will see them all here. By clicking on New Project, you will open a dialog to set some basic properties of the project that you will write. Your algorithm and all calculation results will be stored within a project. We first define a new name of the project. Let's call this Entanglement example. We then choose the backend for executing the algorithm. As a standard user, you can only select the standard simulator backend. So let's select that. Then you set the number of qubits required for your algorithm and the number of times you want to execute your algorithm, called the number of shots. Since quantum algorithms are probabilistic by nature, you will also need multiple shots to get some statistics on your result. A couple of hundred is usually sufficient. The number of qubits and the number of shots can also be changed later. Make sure that the number of qubits is never more than the actual number of qubits that is used by the algorithm. With every extra qubit, the amount of memory that is needed for a simulation doubles, and the simulation time will quickly increase if you use too many qubits. Setting this number to the exact amount you need ensures that you get your results as quickly as possible. For now, you can forget about the error model option. Make sure you leave it to No Error Model. You are now entering the editor. On the left side, you see your quantum program, which is now still empty. At the bottom, you see a visualization of the program in circuit notation. On the right, you can get some information about the backend that will be used to run the algorithm, and a list of instructions that you can use to write your quantum program. Each instruction links to the knowledge base to get more information about this operation. You can also use copy the command to your clipboard and paste it at any required position in your algorithm. Instead of using the copy and paste commands, it will be more efficient to just type your commands in the editor. To complete our entanglement example, we now do a controlled NOT operation between qubit 0 and qubit 1. The final step would be to measure the qubits, but for most simulations it is much more efficient to remove the measure statement. So we will comment it out here. If you now click on Run, the experiment is about to be executed on the selected backend. You can change the name of the experiment and have the option to change the number of shots here. Because we removed the Measure All command, the simulator is able to highly optimize the simulation, resulting in a fast execution. The Learn More link will tell you how this works and what the finer details are of this method. Make sure you check this out thoroughly, because it can make the difference between a simulation taking 30 minutes or just a few seconds, which will make your life much easier. When we click on Run, the program is sent to the selected backend. We can now go back to run the same experiment again, or we can return to the editor. In order to see the results of our algorithm, we click on Results at the top. Here we see our experiment with the date of execution, the backend that was used for the execution, and whether the simulation was optimized or not. If we click on the name of the experiment, a histogram will show the distribution of the outcomes over all measured outcomes, effectively showing the probability of measuring those specific states. As you see here, there is a correlation between the outcomes of the measurement on qubit 0 and on qubit 1. Whenever qubit 0 measures 0, qubit 1 also measures 0. And whenever we measure a 1, we measure a 1 on both qubits. This correlation between the measurements is the result of the entanglement between the qubits. This brings us at the end of this video. If you are not familiar with quantum computer programming yet, or you want to get more details about quantum computers, qubits and entanglement, there are a lot more videos and online courses available. You can find them all through the QTech Academy website at qtech.nl/academy and go to online learning.